Hello, today we are going to move on in our factoring unit, but before we learn how to factor bigger polynomials, I want to review what we did last time, which was learning how to factor out a greatest common factor. So last lesson we focused on just identifying a greatest common factor, but most of the time when you're using them, you're actually going to be taking out the common factor from the polynomial. So I want to teach you how we write that. So when we learned how to do our greatest common factor, first we want to find the GCF, but then to actually write our answer, we're going to divide every term in your polynomial by that greatest common factor. So you're going to write the greatest common factor on the outside of the parentheses, and then whatever is left over is going to go on the inside of the parentheses. So for example, if we have 2x squared plus 6x, we would want to break up each of our terms. So for 2x squared, we can write it as 2 times x, and then 6x, we can break the 6 into 2 and 3, and then we have the 1x. So if we look at our two groups when they're broken apart like that, we see they both have a 2, and then we can take 1x away from this one and 1 away from this one. So our greatest common factor was 2x. So last time we would just stop there, and you guys were just identifying what that is. But how we now want to write our answer is you're going to take that greatest common factor and you're going to write that in the front, and then whatever is left over from when you take away the greatest common factor parts is going to go on the inside. So if we look at this term right here, we took away a 2 and an x, but we had 1x left over. That's going to go on the inside. And then on this one we had a 3 left over, and that's going to go on the inside. And you should always have as many things on the inside of the parentheses as you started with. So if I started with 2 terms, I need to have 2 things on the inside of my parentheses. If I have 3 things that I start with, I need to have 3 things on the inside. So however many original terms you start with is how many terms you should have on the inside of your answer as well. So your greatest common factor goes here in the front, and then this is the leftover part, or the remaining part, goes on the inside of the parentheses. So let's practice a couple more doing that. So on this one, notice that both of these have negatives at the front. I picked that because I also want to show you today that we don't like our first term to be negative. So whenever that first term is negative, we're going to take a negative out in order to make it positive as well. So kind of keep that in mind, but we're still going to break it apart the same way that we learned last time. So for -9, we know that 9 breaks into 3 and 3. So I'm going to write this as a -3 times 3, so that we have that negative there. And then we have a -12x cubed. So 12 breaks into 3 times 4. So let's do a -3 times 4, and then we have x cubed, so x times x times x. So now we can find our greatest common factor. We see both of them have a 3 in it, but I want to take out that negative as well because we don't like the negative to be on that first term. And then I can't take any x's away because our first term didn't have any to give up. So our greatest common factor is just going to be a -3. And now if I want to actually factor out, which means to write our answer with the greatest common factor in the front, and then the parentheses, write whatever is remaining on the inside. So I'm going to write that -3 in the front. And now I'm going to look and see what's remaining and put that on the inside. So we have a 3 here, and notice that it's positive now because we took this negative out with the greatest common factor. So we have a +3. And then on this term, we had a 4 and then 3 x's, which is x cubed. And then as well, we took the negative away from this one. So instead of having a minus sign, this 4 is now a +4. So this is going to turn to a plus. So we like that first term to always be positive. And by taking out that negative, we now have a positive term, which is how we like to write it. So that would be your answer. So notice how they phrase your instructions on your problems. If they just say find the greatest common factor, you would just need to find the -3. But if they tell you to factor out the greatest common factor, they want you to write it in this format with the greatest common factor in the front and then whatever's remaining on the inside of the parentheses. Okay, let's do this again. So we have negative 2 plus 2b. Well, 2 is prime, so we can't break that down anymore. So it's just going to be negative 2, and then plus, we can write that as a negative 2, or sorry, plus a 2b. And so notice that first term is negative again. We don't like that. So I'm going to make my greatest common factor be a negative 2, even though this one's not negative. So don't worry about this sign being different. We don't like this first one to be negative. So I'm going to take a negative 2 out. And remember, essentially what you're doing is you're taking out the greatest common factors is the same as dividing. I have a lot of students make a mistake right here when they think, oh, I'm taking the negative 2 away, I'm putting it in the front. There's nothing that's going to go in here because there's nothing left over. But if I started with 2 terms, I need to have 2 things on the inside of my parentheses. So how I want you to think about it is essentially factoring out is the same as dividing. It's like taking this negative 2 and dividing it by that greatest common factor. Negative 2 divided by negative 2 is a positive 1. Anything divided by itself is 1. That is what is going to go on the inside here. So nothing ever is going to just disappear. You should always have something in the place. So if I started with 2 things, I need to have 2 things in here still. So we'll always keep that in mind. That's a really common mistake I see students make. And then same with this one. If I take a negative 2 away from a positive 2b, and you can think of it as dividing if that helps you. If I do 2b divided by a negative 2, well, 2 divided by negative 2 is negative 1. And then we have that b left over. So it's like we have a negative 1b. We don't really need to write the 1, so we could just write this as a negative b instead of a negative 1b. And that's how you're going to want to write it. But whenever you have that negative first term, we want to take that negative out. And essentially what it's going to do is it's going to flip all of the signs. So notice we started with a negative positive. And then now we have a positive negative pattern. So taking that negative out just flips those signs around. Okay, so that is what you will be doing for factoring out a greatest common factor. So again, notice the directions. If they say to factor out, they want you to write it with that greatest common factor in the front and the remaining parts on the inside. You can do it written out like this and take the greatest common factor and put it in front, and whatever's left over, put it on the inside. Or you can think of it as dividing. So take each term and divide it by that greatest common factor, and whatever remains goes on the inside. So however your brain likes to think of it, do that. So now that we've gone over factor by grouping again, or factoring out a greatest common factor, we are going to get into factored by grouping, which is going to be a new method to factor things that have more than 2 terms. So we're looking at polynomials with like 4 terms or 3 terms. Today we're going to look at just doing ones that have 4 terms. And actually 4 terms is easier than doing 3 terms. Sometimes kids get intimidated by having so many terms, but it's actually not as bad as doing 3 terms. So when you have something with a lot of terms like this, we can't always find a greatest common factor that goes into all 4 things. So like these first 3 have an x we could take out, but I can't take an x away from the 12. These ones we can maybe take some numbers out, but I can't take a number away from the x cubed. So it's really hard to find a greatest common factor between all 4 things. So what we do is we just kind of split it in half. You're going to take your 4 terms and you're going to group them into 2 groups of 2. And that's just going to kind of break apart our problem and make it a little bit easier to handle. Once you break apart into 2 groups of 2, then you're going to find the greatest common factor for each one. So for example, for x cubed minus 3x squared, for x cubed we can write it as x times x times x, and negative 3x squared we can do negative 3 times x. So we can take 2 x's away from each one. So that means x squared is going to be my greatest common factor. So if I factor it out, the greatest common factor is going to go in the front, and the remaining parts are going to go on the inside. So this one had an x left over, and this one had a minus 3 left over. And then we just repeat that process with the second group. So if I look at 4x minus 12, for 4x, we could break it into 2 and 2, but looking at 4 and 12, 4 goes into both 4 and 12. So I'm just going to keep it as a 4 times an x. But then I'm going to write 12 as 4 times 3. So we can see here our greatest common factor is a 4 for that group. So that 4 is going to go in the front, and then the leftover parts go on the inside. So we have x minus 3. So looking at our two groups, notice that the insides match. They're both an x minus 3. We need them to match every time. So if the insides of your parentheses don't match, it's kind of your checkpoint to know that you did something wrong up here. So go back and fix it. They will always match if you did it correctly. So here's kind of your halfway check to make sure that you've done it right. So they're both an x minus 3, which is good. That means I've done my problem right. And now we just need to write our answer. So what we're kind of doing essentially is both of these terms now have an x minus 3 on them. This term has an x minus 3 and this term has an x minus 3. So in a way, the x minus 3 is now their common factor. So we're going to factor out the common part. We're going to take the x minus 3 away. That's going to go in the front, and then whatever's left over is going to go on the insides. So x squared and 4 are going to go inside. And since this was a positive 4, we're going to write it as a plus 4. And that's going to be your answer. So the steps are in right there too, but I think it's a little bit easier to see someone actually work through it. So that is factor by grouping. So we call it factor by grouping because you're putting things into groups to do it. So let's try some more. Here are the steps again. Step 1 is you want to put them into two groups of 2. And then when you're in each group, you're going to take out the greatest common factor from that group. And then that should match. You should have the common group. That's your common factor. You're going to take that out front and then write your answer out. So let's look at this example right here. First step is we're going to break it into 2 parts. So I'm going to do those 2 groups of 2. And then now we're going to look at the 2 terms on this group, 27p cubed and 9p squared. So looking just at the numbers for 27 and 9, I know that 9 goes into 27. 9 times 3 is 27. So 9 is going to be our common factor for the number. And then we have a p cubed and a p squared. So since this one has 2 p's to give up, we can take 2 p's away from this one as well. So we're going to take a p squared out. So if I write my greatest common factor in the front, the 9p squared, we need to get what's left over on the inside. So remember, essentially you're dividing 27p cubed divided by 9p squared. Well, 27 divided by 9 is 3. And p cubed divided by p squared is 1p. So 3p is what is left over. Now we look at our second term, 9p squared divided by 9p squared. Well, 9 divided by 9 is 1. P squared divided by p squared is 1. Whenever you divide something by itself, you should get a 1 back. Again, that doesn't disappear. I have a lot of students make this mistake where they're like, oh, I took a 9p squared out. That just goes away. And they just put just the 3p on the inside. But remember, if I have 2 things here, I need to have 2 things here. So don't forget to put that 1 there when you end up taking out the entire greatest common factor. You should still have a 1 here. Okay, let's look at the second group, 18p plus 6. So first, just look at your numbers and think, what is the common factor there? We could do 2 goes into 18 and 6, right? So it is 3. But we want the biggest one. 6 also goes into 18. So 6 goes into 6, 6 goes into 18. That's going to be for our number. And then this one has a p, but this one doesn't. So we can't take a p out. So all we can do is take a 6 out. And again, think of dividing it by 6. Well, 18p divided by 6. Well, 18 divided by 6 is 3. And then the p will stay on there. And then 6 divided by 6 is 1. So again, don't forget that 1 there. Here's your check. These should match. They're both a 3p plus 1. So that means we did our problem right. So now the 3p plus 1, these are our common groups. So we're going to factor that common 3p plus 1 out to the front. And whatever remains, that 9p squared and the 6, those are going to go on the inside. So we have our 9p squared. And then the 6 was positive, so we're going to keep it as a plus 6. And that's your answer. Okay, hopefully we're getting those steps down a little bit more. Let's look at this guy. We have our 4 terms. So first we're just going to break it into 2 groups of 2. Then at each group, we're just going to find the common factor between those 2 terms. So if you want, you can still do it the long way, which would be to write out all of the different parts. I have some students who prefer to do it that way every time. So for like 2p squared, I could write that as 2 times p, and 4p I could write as 2 times 2 times p. And then we see that they both have a 1, 2 they can give up, and 1p that we can give up. And so then that would be your greatest common factor, the 2p. And then if we take 2 p's away, we have 1p left over. And then on this one, it has a 2 left over. So you can do it that way. If you want to write everything out. A lot of students start to skip that step though and kind of just do it in their head. Whatever you feel comfortable with or whatever helps you get the right answer would be the best way to do it. So if you like to write that out, go for it. If you can do the numbers in your head and go straight from here to here, that's great as well. And then for 3p plus 6, I'll write this one out the long way just to kind of be consistent. 3 is prime, so we can't break that up, so we can just do 3 times p, and then 6 we can do 2 times 3. So we see here their common part is just the 3, so that 3 goes out in the front, and then the p plus 2 goes in the parentheses. And then here's your check. Both of our insides match, so that means we did it right. So take that matching part and write that in the front, p plus 2. And then the leftover pieces, 2p and 3, are going to go on the inside of the second group, 2p plus 3. And that would be your answer. And the nice thing is you can always check to make sure your answer is right. If you want to make sure your answer is right, like say you're on the ACT and you don't want to get anything wrong, all you would need to do is FOIL it. If I multiply these together, I should get this back. So if I times it, I could do p times 2p is 2p squared. P times 3 is 3p. 2 times 2p is 4p. And then 2 times 3 is 6. And so then we see it matches. 2p squared. My p's are in different places, but that's okay. I have 3p, and I have 4p, and I have 6. So I have all my parts. And you could flip those in the other way and it would still be okay. So we're good. So you can always check it. If you're like taking your test, you want to make sure you did it right. You can always FOIL it to make sure. Okay, sometimes when you are factoring these, you might have to factor out a 1. So remember last lesson, we learned that sometimes the greatest common factor might just be a 1. There might not be anything in common between the 2 numbers other than 1. So let's look at this one and see what happens. We have our 4 terms. I'm going to group them into 2 groups of 2. In this first group, I have 6x cubed and 3x squared. I know for 6 and 3, I can take a 3 out of both. And then I have x cubed and x squared. We can always take this smaller amount out, so I can take an x squared away from both. And then we just need to get the inside. So think of dividing that by 3x squared. Well, 6 divided by 3 is 2, and x cubed divided by x squared is x. And then if I divide 3x squared by 3x squared, again, that doesn't just disappear. We need to have a placeholder here. 3x squared divided by 3x squared is 1. Anything divided by itself just equals 1. So don't forget the 1 there. Again, that's a really common mistake I see students make. Looking at our second group, I have 2x and 1. Well, 2 is prime and 1 is prime. 2 can't go into 1, so I can't really take any number out other than 1. I also only have an x on this term and no x on this term. So when this happens that there's nothing in common, I still need a greatest common factor out in the front. So my common factor is just a 1. So it's kind of like cheating a little bit, the system. We know 1 can go into anything, so 2x, I can take a 1 out of it because it doesn't really matter. So 1's our greatest common factor, and then if I divide it, 2x divided by 1 is still just 2x, and 1 divided by 1 is 1. And that's what we need because we need both of these to be a 2x plus 1. But we need this placeholder here. We can't forget that 1 because when I factor out the 2x plus 1 into the front for my answer, remember we need to fill in the two parts here. So I need that 3x squared. And I need the 1 here. So if I forget that 1, I'm not going to have something to put in my space there. So always remember that sometimes you might run into a situation where the only number you can take out is a 1, and we need that 1, so we can't just leave it blank. And then also you'll run into ones where maybe negatives or signs come into play. So far, all the ones we've been looking at have all been pluses because I've been nice to you guys with that. We have some negatives going on here. So we're still going to do it the same way. I'm going to group it into 2 groups of 2, but notice that this term has a negative on it. I need to bring that negative with inside the group, so don't forget that minus sign there. We're still going to just go about our steps the same way. So first I'm going to look at these two. I see they both have a 4, so 4 is going to be the number part of our GCF. And then we have an n cubed and an n squared. So I can take the smaller amount out, so we can take an n squared out. And then, again, think of it as dividing by 4n squared. Well, 4n cubed divided by 4n squared, the 4's will cancel and just be a 1. And n cubed divided by n squared is just n. So we have 1n left over. And then negative 4n squared divided by 4n squared is negative 1. So we get an n minus 1 there. But when we get to this group, again, we have that negative here we can't forget. We don't like that first term to be negative, like I was saying at the beginning of the lesson. So I see I have negative 6n and 6. I'm not just going to take out a positive 6. I want to take out a negative with it so that I can turn this sign positive. Because if I divide this by negative 6 divided by negative 6 is a positive 1. So I get a positive 1n. If I don't take that negative out, I would have had to keep this a negative n, which doesn't match my positive n in this group, and we want these two groups to match. So we need to take that negative out. And then if I do positive 6 divided by negative 6, well, a positive divided by a negative is a negative. So we get a negative 1 there. But by taking that negative out, my signs in here now match my signs in here, rather than if I had taken out a positive 6, I would have had to keep it as a negative n plus 1. And negative n plus 1 wouldn't match, so that wouldn't have worked. So we need to bring that negative out with us. So kind of keep that in mind when that term is a negative on it. But now that we see that both of these are matching, we are going to take out that matching part as our common factor in the front. And then the leftover pieces, the 4n squared and the minus 6, go on the inside. And that would be your answer. Here. Hopefully we're feeling okay so far. Let's just do a couple more. So here on this one, again, do your 2 groups, but notice that we have that negative there, so make sure to bring that negative in the group. And then just start taking your greatest common factors out. So 3n cubed and a negative 2n squared. Well, 3 and 2, they're both prime and they don't have anything in common. Oh, sorry, you can't even see. We have our 2 groups. Let me hurry and rephrase that. We have that negative here. Make sure you put the parenthesis on the outside so that you can take that negative in with the negative 6n. So for this group, our greatest common factor, 3 and 2 don't have anything in common, so we can't take a number out, but we can take n's out. So you have n cubed and n squared, so that means I can take n squared away. If I divide each of these by n squared, well, 3n cubed divided by n squared is going to be a 3n, and negative 2n squared divided by n squared will just be a negative 2. And then on our second group, remember we have that negative here. We have a negative 6n plus 4. So for 6 and 4, the biggest number that goes into both of those is 2. But I need my signs to match the right way. This is a positive negative pattern. Right now this is negative positive. So instead of just taking a 2 out, I want to take a negative 2 out so that my signs flip the right way. So if I divide negative 6 divided by negative 2, a negative divided by a negative turns to a positive. So you get a positive 3n like I need. And 4 divided by negative 2 is negative 2. So we have that matching 3n minus 2 that we need. So now to write our answer, we have our 3n minus 2 go to the front, and then those matching, or those front pieces, our greatest common factors, go inside their own parentheses. So we have n squared minus 2 in the second group, and that is your answer. And then I think we'll just do one more for sake of time. So we have b cubed minus b squared minus b plus 1. So again, we'll have to probably watch our signs here with those negatives. But first, just do your two groups. Make sure to bring that negative into that second group. For b cubed and b squared, we don't have any numbers to worry about, so we can just take out some b's. We can always take out the smaller amount, so b squared is going to come out. And then if I divide by b squared, b cubed divided by b squared is b, so we have one b left over, and b squared divided by b squared is 1, so we're going to have a minus 1 here. So remember, we need that 1, that doesn't just disappear. Now in our second group, negative b plus 1, they don't have anything in common. There's not a b here to take away from the 1, and there's no numbers to take away. So again, when you have a greatest common factor and you can't find something in common, you're going to take a 1 out. But we're running into that sign scenario again. Notice this is b minus 1. Well, this is negative b plus 1. We want these to match. So I need to take out a negative 1 when I do this. So that if I divide negative b divided by negative 1, that will turn to a positive b. And 1 divided by negative 1 turns to a negative 1. And now I have the correct signs, positive b minus 1. So our matching part goes out front. And then the greatest common factors are going to go on their own group, b squared minus 1. And that's your answer. So that is factor by grouping with 4 terms, law of greatest common factors. Be careful with your signs. Also be careful with the 1s. Again, I see students leaving 1s off all the time and they don't know what they're doing wrong. But you should always have at least 2 things in here if you started with 2 things. So keep that in mind. But if you guys have any questions, as always, feel free to reach out to me. We can set up a Zoom and I can help you. But go ahead and get started on your homework and let me know if you have any questions. Hope you guys have a good day. See ya.